Real-time analytics. That is a topic that is increasingly on everyone's minds. And to kick off this podcast, I want to talk to you about what that even means. Hi, I'm Tim Berglund. Welcome to the first episode of the Real-Time Analytics podcast. The normal format of this show will be me interviewing thinkers, technology leaders, people in the space working with real-time analytics. But for today, for this first episode, I just wanted to spend some time talking about what we even mean by that phrase. It seems to want a little bit of definition. I'm really going to start with the basics. And I hope just a few minutes of conversation here about what this means is a good way to get started, a good way to kind of set some boundaries around what kinds of things we'll be talking about in future episodes. So let's start. Let's remove real time for a moment. We're going to have to build to that because that's a little bit of a troublesome phrase. Let's just talk about analytics. So analytics in contrast to what? Well, broadly speaking, there are two categories of databases, transactional databases and analytical databases, or you could say OLTP, online transaction processing, or OLAP, online analytical processing databases. Now, many of you listening have probably heard those terms. Think about what those things mean, though. Transactions refer to things happening out in the world, right? It can be literal business transactions, exchanging of value. Somebody is giving you money and you're giving them the bouquet of flowers that you sold or whatever it is. There's that. That's a transaction. Transactional database can store an event, potentially. That gets a little hairy. Can store an entity, say a description of me as a person, my name, address, phone number, something about me changes. That transactional database can record that. Those are typical transactional type things. Usually in all those cases, there's something in common. You're interested in a thing. You're interested in kind of this thing. A transactional database is focused on one thing. An analytical database, by contrast, is trying to give you insights into what has happened. So there's this world, there are events, there are transactions unfolding, business is being done, things are happening. The transactional database is recording all that and kind of giving you a snapshot of the current state of the world. And the analytical database is, in a sense, remembering all that and trying to summarize it for you, trying to give you some kind of insight into what has happened. And really what that means in these terms, remember I said the analytical database is focused on a thing, or I say this thing, a transactional database is focused on this thing. The analytical database is focused on these things. There's always a big chunk of stuff that you want. So when you're reading one of these databases, typically transactional database read is of a single row, a single thing. And analytical database read is typically a scan of a bunch of things and in a row and then summarized somehow, right? Because getting a bunch of things back in a result set isn't always very useful. Now, if you do that, that could be a certain kind of transactional use case where maybe you're paging through a bunch of instances of some entity. And if there are too many things, that's hard because you're probably trying to focus on one of them and you have to find it and you have to page. That's a pain. So an analytical database that's doing this big read of lots of things, all those things all at once, not helpful, right? So usually it's doing a read of a lot, some big chunk of values, and then running them through some kind of reducing function. And if we're normal people, we call that an aggregate, right? So you do a read, you filter, you compute an aggregate, and maybe there's even a single value that comes back, right? Like you compute an average. Most of them are not that simple, but that's kind of the very basics of a difference between those two things. The way we think about the format of data in those two kinds of databases is very different, right? In a transactional database, OLTP database, usually the schema is a description of an entity. What is the thing out in the world and what are its properties and how does it relate to other entities out in the world? So all those kind of traditional schema tools apply. Now, most OLAP databases use the same tabular format and the same query language, kind of everything's a SQL database within broad parameters. So, all the schema definition tools look the same. But in analytics, the analytics world, in terms of schema, It's not so much entities and attributes and their relationships to one another, but you're more looking at, you tend to think more in terms of measurements. That term shows up. What's the number that you want to summarize and aggregate? And you might want to slice and dice that measurement in terms of various dimensions. So terms like measurements and dimensions kind of tend to pop up when you talk about an analytics database. And I guess to be specific about that, imagine IoT. That's always fun, right? So smart thermostats. And so the measurement might be temperature. Maybe this is some event-driven system, and like every minute, the smart thermostat is reporting a temperature. And so now you've got this big table of all of these temperature readings, and dimensions of that temperature might be the size of the home, maybe some bucket of how many square feet the home is, the zip code the home appears in. Maybe there's some age of the home, code for EPA Energy Star Zero energy status, or some sort of bucket like that. These are things one might imagine could be dimensions of that measurement. And that's just how you tend to think about schema in those two kinds of databases. So you got analytics, you got transactions. Those are sort of different ways of handling the world. One is you're kind of conducting business, and the other is you're trying to get insight into what has happened. And that's obviously what analytics is all about. Why does that matter? Like, why not just have one database and be able to ask it the same questions? Why do we have specialized databases? Well, reading and writing are fundamentally different in these two use cases. Remember, I said in a transactional database, you're usually focused on one thing. Well, you probably have a lot of things in your database, and likely at any given moment, within any given period of time, there's going to be a small subset of those one things that you actually care about. You'll probably see, and if you're watching the video version, I'm tracing a curve in the air with my finger. If you're not, just imagine a power law distribution, right? Or a Pareto distribution of those things, where a small percentage of the things are the ones that get most of the attention in a transactional database. Sounds like that would be amenable to caching, right? So kind of traditional caching concepts that just the operating system will do with pages on disk are going to help you a lot in the case of the transactional database. But then if you go to the analytical database, now there still might be a current set of data that gets more attention. It's not like everything is going to be uniformly distributed in terms of what measurements and what records and everything you're interested in. But you're doing these big scans, right? That's kind of the mode here, is that there's big chunks of stuff I have to scan across, which is going to tend to be at crossed purposes with the caching of the kind of caching transactional data is going to want. So they just tend to be different. Also, the way you store things on disk is going to be totally different between a transactional and analytical database. A transactional database, you want one thing. So you better store that thing in one place. If I need to look up my user account, I want that poor database to be able to go to disk and read a chunk of stuff off disk and just get in one block, or whatever the device exposes as an API, my whole record. I don't want it to have to look in different places for things, right? But an analytics database, where I'm likely to scan many measurements in a row, I'm going to want all those measurements, so that is all the values of that column, in one place. So if this is a new concept to you, without visuals, this might be tough. But broadly speaking, analytics databases are going to be optimized. They're going to be better optimized if their storage is organized by column, and transactional databases storage will be optimized by row. So it's a huge difference, right? They're not only are they different things, conducting business in the world versus trying to understand what happened. Those are kind of different mindsets, but they lend themselves to very different implementations. So it's a big difference. Just being an analytics database is impactful. And the idea of analytics has a long history. Now, the first businesses to use computers used early mainframes, at least in my understanding of the history. Those were a lot of IBM machines in the 50s. If you're ever in the Bay Area of California, in Mountain View, there's this cool museum called the Computer History Museum. You can actually see some of these machines from coming up on 70 years ago. And those machines were batch analysis engines. You had card readers. Again, you can see some of these. This episode is not sponsored by the Computer History Museum. I just think it's a fun place. But you can see card readers where they'd load in cards and just read in all this data. And group and aggregate and output some simpler summary of that data, maybe some scalar value even in the best case. So those were batch machines. Into the 90s, later on, you had the whole ETL world developing, where you had now kind of a established transactional database discipline of not a lot of discipline of transactional databases existing all over the place. And now we needed a system and a set of practices and a set of tools and a community of consultancies and books and all this kind of stuff to help us get the data from those databases, again, as a batch operation, and load it into a separate database that was optimized for analytics. So the first machines, almost struggled with transaction processing. We just had records and we analyzed them. Then we got systems that were fast enough to be in the loop of transactions and had to build a second system to help us with the analytics. So there's still this batch process. That history is pretty well known. That ETL concept survived 10, 15 years, maybe by some measurements, maybe 20, with kind of only evolutionary changes around the edges. Then big data happened. And suddenly, instead of a star schema in a data warehouse, you've got, what we came to call the data lake. You've just got this big pile of data in a distributed file system or eventually a cloud blob store, and you write all your data in there. You don't worry about the schema or the transforming, or you'll kind of figure that out later when you read it. And so you'll write some job that reads that data, performs the analysis. So it changed in form a lot, but in spirit, from the classical ETL to the more modern data lake, it's still a place where you take your transactions, you dump them, you leave them. When you're interested in them, you go back to them, do some kind of analysis, and get your number out. All of that is fundamentally batch. All of that is going to lend itself towards even efficient, fast, distributed systems with lots of compute and all the resources you can put into all the nodes and everything. It's going to lend itself to relatively long latencies. It's kind of difficult in any of these modern systems to get much done in less than 5 seconds, which, given the sizes of the data involved, seems impressive, but is still kind of a limitation. Which gets us to this phrase, real time. Initially set it aside. I just wanted to talk about analytics. But let's think about the phrase. It's a little disturbing at first because it just kind of sounds like marketing speak. It's after the startup reaches a certain level of maturity and, the engineer founders aren't writing the web copy anymore and the marketing team is, and these terms creep in and, you look at the website, like, what does that company even do? I can't tell what the technology does. Well, there's good reasons for all that. And I want to kind of rescue real time from that world. If it's a term that bugs you, early in my career, I wrote firmware, right? And it had a great crisp definition in that world. It just means predictable latency in the firmware embedded device world. If it's real time, that means for an event to be processed, there's a maximum amount of time that can take. And if it takes longer than that, it's like you got the answer wrong, right? And there are certain systems like that. Helpful, but that's not what we mean here. I mean something a little fuzzier. I want to be specific, but slightly fuzzy. When I say real-time analytics, I mean fast enough to be in a user interface, to be in the interaction layer of an application. So I open a mobile app, I give it some kind of input, enter an address, tap on a thing, do something to it. And now it's going to tell me things about the state of the world. And it's going to go query live data and give me an answer in an amount of time that feels satisfactory to me. So that's fuzzy. All right. That's fuzzier than the hard real-time firmware world, but it's specific. And that's what I mean by real-time analytics. I'll wait for the query in a user interface without a little spinny thing, without it feeling broken or dead or saying, I'm going to switch to a competitive app or close the tab or anything like that. It's fast enough to use in the interaction layer. That's what I mean by real-time analytics. And ideally, a database that's a real-time analytics database, this is kind of what I do with Apache Pinot and here at Startree, that's a database that can give you query latencies that are fast enough to be able to answer queries there. Now, there's a lot more to the world of real-time analytics than just a database like Pinot, and this podcast is going to cover all kinds of related topics. But that's what I mean. That's analytics, And that's what I mean by real time. Of course, we are not quite done yet. There's some implications there, right? I talked about a user interface, and there's sort of this general implication of something consumer facing, right? And in the old world of analytics, the original things with the punch cards and the machines with cases made out of big, thick pieces of steel and blinky lights on the panels, all the way up through, Kimball, Inman data warehouses in the 90s up to Snowflake today and Tableau, the most modern data warehouse, cloud-based data warehouse you can have today. All of those things are roughly oriented to the internal decision maker, somebody inside the company. And it's okay if that person has to wait a few seconds for an answer, or even a minute for something. That's still pretty fast for that internal decision maker. Real-time analytics, it's possible as a synonym to call them user-facing analytics. This is stuff that people can use in user interfaces. So there's this idea that it's serving people outside of an organization, customers, users, not people inside the organization. That's, I think, inherently tied up in the notion of real-time analytics. It doesn't just mean faster than we expect. There really is something different about the community of people who are being considered as decision makers. And, this podcast, this discipline, this whole area, this is a new and emerging subcategory. There are a lot of businesses yet to see this power, but the folks who have, the early adopters, they're seeing that it's incredibly interesting to expose the state of the business, the state of the world as the app, business, service sees it, to the users of the business. That's huge. You can create much more compelling experiences by including them in the community of decision makers. They get a more valuable interaction with the app, service, business, whatever it is. And that's going to be stickier. They'll retain better. They'll, be interested in paying a higher price because they get more out of it, right? So there's a lot on the business side of things of benefit being realized by the folks who are there. In terms of the way a database behaves, and again, I sort of think with this database bias. There are streaming systems in the world of real-time analytics, but just generally, where does this kind of push us to think? I think there are three non-functional requirements that emerge as important. And when you look at the history of how real-time analytics systems are emerging, these things tend to come out. And those are concurrency, latency, and freshness. So now that it's user-facing, suddenly it's not just three executives wanting a dashboard refreshed, or, in the old days, a report printed. That's not very high concurrency at all. That database doesn't need to handle very many users at all. Now suddenly it's your entire operating user community. That could be thousands, tens of thousands, hundreds of thousands, could be millions of people, depending on the service that we're talking about. So this database needs to handle much higher concurrency than traditional analytics databases. It needs to, already made this clear, needs to answer queries faster, right? Spinning up a job and sending out workers to the nodes that the data is on and getting them going and coming, all that kind of stuff that it takes a few seconds to do all that coordination. That was good for the dashboard generation, the previous generation. That's not how we do things now. We need latencies in that interaction layer under 100 milliseconds, really, and on average, a lot less than 100 milliseconds for those core queries. So latency and freshness. You want data that's brand new. Things have happened in the world, and you want to expose those things to your users right away, like within seconds through a streaming pipeline. Which, I want to explore that term for a minute. Streaming. So where does this data come from in the world of real-time analytics? Well, it's perfectly fine for there to be batch data sources, for there to be a data lake or some gigantic repository of CSV data. I've got I won't elaborate on this, but a project my team's working on where there is a bunch of CSV data sitting somewhere. We're going to do some analysis on it in Pinot. That's fine to do. But the real orientation here, and I think the real genesis of real-time analytics as a category, has to do with the rise of streaming, right? So typically these are going to be things that are either literally stream processing systems, I think like a Flink, where there's an event, we process it, we do some analysis. There's always this real-time result that's unfolding as events happen, or a thing like Pinot, where there's a connection to Kafka, and I'm ingesting events as they land in a topic, and as soon as I ingest them, they're available for querying. So there's probably some notion of streaming tied up in this, and I think that's going to be just a broad technology category that comes up a lot on the podcast. So in summary, what are we talking about in the world of real-time analytics? We're talking about systems that are intended to provide insights into what has happened. So they're not dealing so much with making a decision about an event or remembering this thing happened, this is the current state of this entity, but more aggregating over recent history and maybe longer history to provide some kind of summary of what has been the case. And the idea there is always to provide actionable insights to the people looking at the data. And in some cases, a thing I hope we'll get to explore, actionable insights to other processes, other machines that are consumers of real-time analytics. That is not off the table at all. These results can be consumed by people or consumed by machines. Again, there's this orientation towards aggregating a measurement. There's usually a focus on there's some number out there, and we want to filter and group by various dimensions associated with that number, or individual measurements of that number, and provide those either in a streaming context or from batch data or from some combination, either from a streaming process or from a database to the result, to whoever's consuming that result. So that's, again, just kind of the definition of analytics there. We're probably going to think a lot about things like concurrency, latency, and freshness. And that's because real-time analytics doesn't make a lot of sense outside of some kind of user-facing orientation. So you should expect that kind of notion to crop up a lot. I hope in future episodes even to explore things strictly in the user interaction layer, right? Not the database backend or anything like that, but like what's happening in the front end as this revolution unfolds. I think that's important stuff. And always a connection with some kind of streaming technology, some kind of event-driven architecture. That's going to be a thing that tends to show up a lot. So there you go. That's what we mean here on the Real-Time Analytics Podcast by real-time analytics. I hope that breakdown, that discussion, that taxonomy, whatever you want to call that, is helpful, provides a good framework for how we're going to move forward. And I look forward to having you as a listener every week. Thanks. And there you have it. The Real-Time Analytics Summit is coming up on April 25th and 26th, 2023 in downtown San Francisco. You can register at rtasummit.com, and if you use the promo code PODCAST30, that's PODCAST30, you get 30% off your registration. I really hope to see you there. And hey, if you feel compelled to help us spread the word more and grow the real-time analytics community, you can give this podcast a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, please subscribe to our channel and, of course, hit that notification bell. And hey, you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. I look forward to talking to you again in the next episode.